Hello, Honors Chemistry, and welcome to Chapter 8 and Chapter 13 Review. First, we're going to start by refreshing our memory on all the conversion factors that we've learned to date. Not all of them, but most of them, because obviously we need to know what conversion factors we have, right? And then, really, most of what we're doing in Chapters 8 and 13 are just, how do we convert between what our given is and what our goal is? So, first we have mole ratio, this being the one new one, right, from Chapter 8. Key because this allows us to convert between, moles of A and moles of B, right? It is the only conversion factor that allows us to convert between two different substances, and in order to do this or use this, we have to have a balanced equation, yes, always. Which means that in order to do this or use one of these, we have to know Chapter 7, so we need to know what types of reactions there are, which some of you guys should review that, right? We also need to be able to write chemical formulas correctly, because if we can't do that, we also can't successfully get our reactions balanced, right? In addition, we also need to know our solubility rules so we can decide what the states of our respective components are going to be, so that way we can correctly answer questions like what mass of precipitate is formed, right? So again, those are the things to review so that you can use mole ratios correctly. Next up, we have molar mass, right? As like the term says, molar mass. This converts between moles of something and mass, and now we're going to start to clarify, of that same something, right? Moles of A and the mass of A, right? For molar mass, right? And more specifically, it's the number of grams equal to 1 mole of that substance, and that information is garnered from, that's right, the periodic table. Next up, we've got molarity, where molarity, abbreviated capital M, allows us to convert between, moles of solute, and volume of our solution, So things to note, our capital M stands for moles per liter, and this only applies to solutions, So we would only ever use molarity if we have an aqueous solution, Or it could be made of, the solvent could be something else, But it only applies to solutions, and that's the only place we would ever use molarity. Next up, we have mass percent, where that allows us to convert between mass of substance A and what? Mass, let me write that better. Mass of solute and mass of my solution, So mass of my solute and mass of my solution. Next up, we have molality, symbolized with a lowercase m, which is, moles of solute converted between kilograms of solvent. And really, we only ever use this when colligative properties, And don't forget that when we're talking about our colligative properties, it depends on the quantity of solute, not the identity of the solute. And, don't forget that if something dissociates, then really we have more solute than it seems, and we can do a calculation to figure out how much actual solute is present, based on our understanding of Chapter 5 and 6. All right, next up we have heat of reaction, which is symbolized with a delta H reaction, where this would be what? Converts between what? Kilojoules and moles, and this would be for a particular reaction, and it'd be tied to your balanced equation, So that would go together, and we would have to have a balanced equation. Next up, we've got density, which converts between, mass of our substance A, whatever A happens to be, and volume of A, So here, also during the lab, some of you guys tried to talk about density in the context of, if I know the density of my solution, then I know how many grams of hydrochloric acid I have, for example. But remember that that's not what that means, So if I define A as a solution, then the mass of my solution is equal to the volume of my solution, Density doesn't allow me to tease out the mass of the component, If we were really thoughtful about our math, we could probably, figure that out a little bit, but that's just not a direct relationship, yeah? All right, then we have our Q equals MC delta T, which allows us to talk about the relationship between heat and mass, right? So joules and mass is what this is often used for, right? If we have a process in front of us where we know a change in temperature and the respective C value for that stock, because again, you're not expected to know the C values for anything except for water, right? Which is 4.184, 4.184 joules per mole degrees Celsius, right? So that you are supposed to know, right? SI prefixes, right? Make sure you go back and look at that table. Avogadro's number, right? 6.022 times 10 to the 23rd particles equals 1 mole. And so it converts between moles and particles, right? And don't forget the words that we have for particles, depending on what we're talking about, right? If we're talking about an element, we would say atoms. If we were talking about molecules, we would say molecules. If we were talking about ionic compounds, we would talk about formula units. If we were talking about an ionic compound dissociating, we would talk about ions, right? So make sure we're thoughtful about our word choices there. And then we have our piece versus whole conversions, and this goes back to chapter 6, right? Where we can use a chemical formula to break down something into what it's made of, right? All right, so summary of our conversions to date. Now, we can take those conversions, kind of like we did a few chapters ago, and sort of map them out, right? Where if we think about at our center, right, we have one unique conversion factor that allows us to convert between two different substances using a chemical reaction, right? So moles of A to moles of B, and that is only ever done using a mole ratio, right? That's the only way we can do that. Using our balanced equation, all that good stuff, right? But then we can think about, again, how all these other conversion factors tie in, right? So for example, we can do molar mass, right? So I can talk about grams of A, right? Or I could talk about grams of B, right? And I would do that again using molar mass and molar mass, yes? All right. Now we can tie in something else, right? So for example, if we look at our list here, oh, there are some that tie into mass, right? Like Q equals MC delta T and density, right? So if I look here, I can tie in a density. I can talk about the volume of A, right? Or I could talk about the volume of B, right? And that would be with density as my conversion factor. Right? We could also talk about, like I said, the Q equals MC delta T, right? So we could talk about joules or heat. If I know enough of the components of Q equals MC delta T, right? And what else do we have that fits in here, right? We also have Avogadro's number, right? Which fits in here, right? So we could go to particles of A. Or we could talk about particles of B. Using Avogadro's number, right? Avogadro's number. And let's see what else we've got. We have... oh, we've got molarity, right? So off of moles, we can also do molarity. So we could talk about volume of A. So volume of A if A is a solution. Or volume of B when B is an aqueous solution. And if we had the respective molarity of each, right? And let's see what else we've got that we haven't used yet. Mass percent, we're not going to put that on here. Molality, heat of reaction, right? So also, if we know moles, we can go to heat, right? So there's another route here. We can go to kilojoules or heat. And we can talk about heat again here, right? And here, this would be if we knew the heat of reaction, right? So there are two routes to talk about heat, right? We can talk about heat if we know Q equals mc delta T and enough information, or we could talk about heat from the perspective of delta H of reaction if that's the information that we have, right? It just depends on what we have access to and what our given versus our goal is, right? Okay, so if we look at this, right, this is a roadmap, right? Just like we talked about before, except now, like I said, it keeps getting bigger, and in the next units it'll get bigger, right? But the point is just to sort of organize all of our conversions, right? So if we were to think about this, we can go from mole A to mole B only using this mole ratio, right? That's the only way to get there. But we have all these other conversions. So for example, a lot of the basic stuff from chapter 8 was going from grams of A to grams of B, right? Where step 1 is you would use a molar mass to get to moles, mole ratio to get to moles of B, and then molar mass to get to grams of B, right? But if I know for example, if I wanted to start at the volume of A and I knew its density, I could go from volume of A, use its density to get to grams, and then hop into molar mass, moles, grams, right? So yeah, it's all the conversion factors. It's amazing how much you guys know, right? So if any of these conversion factors seem fuzzy to you because you've forgotten them, make sure you go refresh on those, right? You'd have sample problems in each of the review packets or mixed practices from those respective chapters. All right. Thanks for listening. In the next video, we will work through a few problems together. All right. Be good, do your homework, and I'll see you soon. Bye.